Welcome to the session on trigonometry and modelling, simplifying a cos x plus or minus b sin x. The objectives for this session are to write expressions of the form a cos x plus or minus b sin x in the forms r cos theta plus or minus alpha or r sin theta plus or minus alpha. Consider expressions such as a cos x plus b sin x, where a and b are constants and can be written as a sine function only or cosine function only. In other words, a cos theta plus b sin theta can be written as r sin x plus or minus alpha or r cos x plus or minus beta, where r cos alpha equals a, r sin alpha equals b, and r equals the square root of a squared plus b squared. We can use the addition formulae to expand sin x plus or minus alpha and cos x plus or minus beta, and then equate the coefficients. Pause the video and have a go at this example. Press play when you're ready to view the solutions. So let's take a look at part A first. We are required to express 5 sin x plus 2 cos x in the form r sin x plus alpha, where r is greater than 0 and alpha is between 0 and 90 degrees. We are also required to give our values of r and alpha to one decimal place. So let's solve this. Recall that the angle addition formula for sine states that r sin x plus alpha is identical to r sin x cos alpha plus r cos x sin alpha. So, if 5 sin x plus 2 cos x is identical to r sin x plus alpha, then we have that 5 sin x plus 2 cos x is identical to r sin x cos alpha plus r cos x sin alpha. And now we can equate the coefficients. So if we equate the coefficient of sin x, we have that r cos alpha equals 5, and if we equate the coefficient of cos x, we have that r sin alpha equals 2. And therefore, r sin alpha equals 2 over r cos alpha, which is equal to 5, equals tan alpha, which is equal to 2 over 5. And therefore, if we inverse tan this expression, we have that alpha equals tan inverse of 2 over 5, which is equal to 21.8 degrees. Let's now gather the key information from the previous slide, as shown here. We're going to use this information to find the value of r. If we square r cos alpha, we have r squared cos squared alpha. If we square r sin alpha, we have r squared sin squared alpha. We also have that r squared cos squared plus r squared sin squared is equal to r squared, since of course cos squared plus sin squared is equal to 1. So r squared equals 5 squared plus 2 squared, which is equal to 29. And therefore, r is equal to root 29, which is equal to 5.4. So we have that 5 sine x plus 2 cos x equals 5.4, which is the value of r, times sine of x plus alpha, which is equal to 21.8 degrees. Now let's take a look at part B. We are required to sketch the graph of y equals 5 sine x plus 2 cos x. So let's solve this. Now from part A, we have that 5 sine x plus 2 cos x equals 5.4 times sine of x plus 21.8 degrees. And therefore, y equals 5.4 times sine of x plus 21.8 degrees. So if this is our graph of y equals sine x, then y equals sine x plus 21.8 degrees has shifted left by 21.8 degrees, as shown by the red line. In order to obtain y equals 5.4 times sine x plus 21.8 degrees, we then stretch the graph by a scale factor of 5.4. And so here's our graph. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's solve part A first. Suppose f of theta equals 3 cos theta plus 4 sin theta. We are required to express f of theta in the form Rcos theta minus alpha, where r is greater than 0 and alpha is between 0 and 90 degrees. We are also required to give our values of r and alpha to 1 decimal place. So let's solve this. We're going to set 3 cos theta plus 4 sin theta equal to Rcos theta minus alpha. And so, using the addition formula to expand cos theta minus alpha, we have this expression here. So now we can equate the coefficients. Equating the coefficients of cos theta gives us that 3 equals r cos alpha. And equating the coefficient of sin theta gives us that 4 equals r sin alpha. Hence we have that r sin alpha over r cos alpha equals tan alpha, which is equal to 4, which is the value of r sin alpha, over 3, which is the value of r cos alpha. If we inverse tan this expression, we have that alpha equals 53.1 degrees. We also have that r squared cos squared alpha equals 3 squared plus r squared sin squared alpha equals 4 squared. Now r squared cos squared alpha plus sin squared alpha is of course equal to r squared. And therefore r squared equals 3 squared plus 4 squared, which is equal to 25. Therefore, r is equal to 5. Now we can plug in these values of r and alpha into the expression for 3 cos theta plus 4 sin theta to give us 5 cos theta minus 53.1 degrees. We've plugged in r equals 5 and we've plugged in alpha equals 53.1 degrees as shown. Now let's take a look at part B. We are required to solve for theta between 0 and 360 degrees the equation 3 cos theta plus 4 sin theta equals 5. So let's solve this. From part A we have this equation. And so if we substitute the value of 5 into this expression, we have that 5 cos theta minus 53.1 degrees equals 5. And dividing through by 5 gives us cos theta minus 53.1 degrees equals 1. And this occurs when theta minus 53.1 degrees equals many values, including minus 360 degrees, 0 degrees, 360 degrees, and so on. Since theta is between 0 and 360 degrees, we have that theta equals 53.1 degrees, which lies in the first quadrant. However, as you can see from the cast diagram, we also have that cos is positive in the fourth quadrant also. Therefore, theta equals 360 degrees minus 53.1 degrees, which is equal to 306.9 degrees. Now let's take a look at part C. We are required to find the maximum value of f of theta equals 3 cos theta plus 4 sin theta and the smallest positive value of theta for which it occurs. So let's solve this. From part A we have that 3 cos theta plus 4 sin theta equals 5 cos theta minus 53.1 degrees. Therefore, we're going to try to find the maximum value of 5 cos theta minus 53.1 degrees. This, of course, occurs when cos theta minus 53.1 degrees is equal to 1, since this is the maximum value of cos. And this occurs when theta minus 53.1 degrees equals, for example, minus 360 degrees, 0 degrees, and 360 degrees, as well as an infinite number of other values. So the smallest positive value of theta is therefore 53.1 degrees. This brings us to the end of this session. If you have understood its contents, you should be able to write expressions of the form a cos x plus or minus b sin x in the forms r cos theta plus or minus alpha or r sin theta plus or minus alpha. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.